This is on the homework for this week. This is homework 4 in sections 3.1 and 3.2. I'll go through a few questions today, and I should be able to go through a few more tomorrow. And we'll just get started. We have questions 1 through 8, and then 9 through 54 odd. So it says, we know that cosine is an even function, while sine and tangent are odd functions. What about cosine squared, sine squared, tangent squared? So we have to recall the definition of even function and the definition of odd function. You have to have enough space to. Okay, so the definition of an even function is f is an even function if, when I plug negative x into it, the negative sign cancels and gives me back the original function. X squared is an example of an even function because if I have my function like that, I plug in negative x, that means I get negative x squared, which is negative x times negative x, the negatives cancel, and I'm left with x squared, which is my original function. This is even. The reason it's called even is because it turns out for polynomials, for polynomial terms, if the term is an even degree, it ends up being an even function. So that's why we call the property even. Odd functions are ones where if you, this is even, this is odd. If I plug in negative x, I get negative f of x. It's almost like I can factor out the negative. And in some functions, you actually can literally factor the negative out. But in other functions, it's just a property that is not exactly factoring, it just ends up that way. So if I let f of x, sorry, if I let my function g of x be, say, x cubed, and I plug negative x in, I get negative x cubed, which is negative x times negative x times negative x. There are an odd number of negative signs, so I end up with a negative. X times x times x is x to the third, and this is equal to negative, this part is g of x. So I plugged in a negative, and it's the same as multiplying by negative at the end. So these are our definitions. We want to look at, it said, what, sine squared, cosine squared, and tangent squared. Okay, so if we have sine squared of x of negative x, what does that equal? Well, we know sine is odd, so this is the same as negative sine of x squared, which is sine squared x. So this means that this is an even function. If I plug in x, the negative sign cancels away. Cosine squared of negative x is the same as cosine of negative x squared, which is the same as cosine of x squared, which is cosine squared x. This is also even. If I do it with tangent, this is the same as tangent of negative x squared, which is the same as negative tangent of x squared, which is equal to tangent squared x. It's also even. All of these are even. And in general, actually, if f is a function that is even or odd, then f of x squared is even. You're not asked to prove this part, but turns out this is true. Let me show you why. So suppose f of x is even, then f of negative x squared equals the square of f of x, because even means these two things are equal. And that is done. Right, scrolled sideways there. Alternatively, suppose f of x is odd, then f of negative x squared equals negative f of x squared equals negative f of x times negative f of x. The negatives cancel. This gives us f of x squared, and we're done. So that's neat. Let's see. I think I'll let you just worry about evens and odds on your own. Let's look at these. 9 through 54 odd. Finding exact values of trig identities. You can use your unit circles for that and your reference angles. I'm going to pick 13 just as an example. Cotangent of 250. Okay. Draw a diagram. I know this is 0, 90, 180, 70. So it's going to be in here somewhere. That means that my reference angle is going to be, what, 75 degrees? That's interesting. Guess we've learned a few trig identities at this point of the book. Okay, very cool. So, yeah, because we have angle sum identities down here. That's good. Cotangent of 255 is the same as cosine of 255 over sine of 255. It's also equal to, we have to decide the sine later, of cosine of 75 over sine of 75 degrees, because that's the reference angle. Now we have to figure out a way to write 75 degrees in a way that is a sum of angles we know. We know from our unit circle 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. These are on our unit circle. And I notice that if I add 30 and 45, I get 75. So this is the same as, and we'll decide the sign later. That is the polarity, positive, negative. This is cosine of 30 degrees plus 45 degrees over sine of 30 degrees plus 45 degrees. We use our trig angle sum identities to split this into cosine of 30 degrees times cosine of 45 degrees minus sine of 30 degrees over, sorry, times sine of 45 degrees all over sine of 30 degrees cosine of 45 degrees plus sine of 45 degrees cosine of 30 degrees. And a plus or minus sign in front of that. Now we use our memorized memorized trigonometric values from the unit circle. And we get cosine of 30 is root 3 over 2. Cosine of 145 is 1 over the square root of 2. Plus and minus sign there. Minus sine of 30 degrees is 1/2. Sine of 45 degrees is 1 over the square root of 2. Sine of 30 degrees is 1/2. Cosine of 45 degrees is 1 over the square root of 2. Sine of 45 degrees is 1 over the square root of 2. And cosine of 30 degrees is root of 3 over 2. Okay. Very good. I notice that I can cancel the 1 over square root of 2 from all terms. I can factor it out of the top, factor this out of the top, factor this out of the bottom, and cancel all of those. This gives me 3 over 2 minus 1 over 2 over 1 over 2 plus root 3 over 2. There's a plus or minus there. And I also notice that if I multiply this by 2 over 2, I can cancel the denominators. This 2 gets multiplied in here and cancels there and there. Same thing down here. This gives me plus or minus square root of 3 minus 1 over 1 plus the square root of 3. Now let's figure out which sign we're in. Well, this is in quadrant 3. Everything's positive in quadrant 1. All cosine and secant are positive in quadrant 2. Tangent and cotangent are positive in quadrant 3. Okay, quadrant 2. This is quadrant 4. In 1, everything's positive. In 4, cosine and sine are positive. In 3, tangent and cotangent are positive. And quadrant 2, sine and cosecant are positive. So we're going to use the positive because we're in the positive quadrant. Our final value is going to be cotangent of 255 degrees is equal to the square root of 3 minus 1 over 1 plus the square root of 3. Okay. Let's go to one more problem, maybe. Next section has, this is a similar thing. We don't need to figure out the reference angles because we are given these values here. Okay. Next one. Or let's see if we have some identities to prove. Maybe we can one of these. And let's do an odd one. Let's do this one. And then we'll wrap this video and we'll get back to it tomorrow. So, have cosine of theta minus pi equals negative cosine theta. Here we go. So, the left-hand side is where I'm going to start. The angle difference identity says this is equal to cosine of theta, cosine of pi plus sine theta sine pi. Not so bad. This is equal to -1. This is equal to 0. So we get -1 times cosine of theta plus the whole thing goes to 0 there. And that's the right-hand side. So we are done. Okay. Let's call that for today. We'll do some more identity proofs tomorrow. So, talk to you all next time. Good luck with the homework. Bye.